This is a really interesting pre-university exam question. Simplify 2e to the I pi over 6 plus minus 1 add root 3i. Now normally when you are adding complex numbers, it's much preferable to have both numbers in the general form rather than in the exponential or the polar form. Here we have one in the polar, one in the general. So the natural way that you would solve this question is by converting the polar or exponential to the general. This question does have a twist though, which I'll explain in a minute. But first of all, let's do the way that you would do if you had the choice. 2e to the I pi over 6 is one of the 16 must-know complex numbers that we discussed in the previous Grades to the Academy video. So we know that that is root 3 plus I. So all we need to do now, adding the two numbers together, is root 3 plus I add minus 1 add root 3i equals adding the reals and adding the imaginaries gives us root 3 minus 1 plus I 1 plus root 3. Et voila, we solved the question. Now unfortunately this question had 5 multiple choice answers, all of which were in exponential form. So that was guiding us or leading us to actually having to answer this addition in exponential form, i.e. converting this general form into exponential form and then adding. And that, as we shall see, is actually a little bit harder. To do that, we're going to need the following trig identities. Sine A plus sine B equals 2 sine A plus B over 2 cos A minus B over 2 and cos A plus cos B, that's B, sorry, cos A cos B equals 2 cos A plus B over 2 cos A minus B over 2. And you will notice, and we're going to use this, that both of these have cos A minus B over 2 in them, which we will be able to take out as a factor in a minute. So what we need to do is we need to convert the general form part of this addition into the exponential form. And again, fortunately, minus 1 plus root 3i, as is the general case in most exams, is one of the 16 must-know complex numbers that we've already discussed in the previous Grades to the Academy video. So we know that that in polar form is 2 cos of 2 pi over 3 add I sine of 2 pi over 3. We also know it's trivial to note that 2e to the I pi over 6, which is the first term, is 2 cos of pi over 6 plus I of sine of pi over 6. That's just converting it from the exponential to the polar. So we now have both of our complex numbers in polar form, and so we can add them. So let's add the reals. We can take 2 out as a factor, and we've got let's put the reals together and the imaginaries together. So we have 2 cos of pi over 6 plus cos of 2 pi over 3 plus I sine of pi over 6 add sine of 2 pi over 3. Okay, so we have our equation now, and now we use our trig identity, the cos A plus cos B here, and we use the trig identity sine A plus sine B here, and that will give us the following. Let's just, we do have to be careful here, so we've got the 2 outside of the brackets. That will give us 2, so cos A plus cos B is 2 cos of pi over 6 plus 2 pi over 3 over 2 cos pi over 6 minus 2 pi over 3 over 2 plus I, and let's put that in another bracket, 2, and this is the sine A plus sine B, bracket, sine pi plus 6, pi over 6 plus 2 pi over 3 over 2 cos pi over 6 minus 2 pi over 3 over 2. So you can see that this is far more complicated than just adding the general form. But fortunately, because we can take out, as we mentioned earlier in this video, we can take out a factor, cos pi over 6 minus 2 pi over 3 over 2, and we can take 2 out as well, and that gives us 4 cos of pi over 6 minus 2 pi over 3 over 2, and inside the brackets we have cos of pi over 6 plus 2 pi over 3 over 2 plus I sine of pi over 6 plus 2 pi over 3 over 2. And pi plus 6 plus 2 pi over 3 over 2 is 5 pi over 12. So we can now rewrite this as, and let's just work out what cos of pi over 6 minus 2 pi over 3 over 2 is as well. Well, pi over 6 minus 2 pi over 3 is minus 3 pi over 6, divided by 2 is minus 3 pi over 12, so it's minus cos, so that's 4 of cos minus pi over 4, times by cos of 5 pi over 12 plus I sine 5 pi over 12. And cos of minus pi over 4 is 1 over root 2 by basic trig. And so therefore we are left with 4 over root 2 e to the I 5 pi over 12, just converting this polar form here into exponential, which is 2 root 2 e to the I 5 pi over 12. Unfortunately, that was one of the 5 multiple choice answers, so that was the that was the solution. Now, clearly the general form was easier, and somebody has asked whether or not we could have just taken the general form and converted it into the exponential form, and you can do that. So just remembering, this is the answer in exponential form. And in general form, we've already worked out that the answer was root 3 minus 1 plus I 1 plus root 3. They are equivalent complex numbers, but is there an easy way of getting from this, which was trivial to find by converting the polar form into general and then adding them up, to this, without having to go through all of our trig addition formulae? Well, you can. It's a slightly lesser known triangle, but there is another triangle in addition to the just drawing the triangles that we already know, 1 1 root 2, and this is pi over 4 here, and the other one which is root 3 and 1, and that is a 2, and this is pi over 3. There is one more. It's not quite so well known, and you certainly wouldn't be expected to know it outside of an Olympiad, but there is one more triangle which is 1 plus root 3, 1 minus root 3, and 2 root 2. This triangle is another right angle triangle, and in actual fact this angle here is 5 pi over 12, meaning that this angle is pi over 12. It's not quite so well known, but if you do know that triangle, then you can see that in the Argonne diagram, the answer that we got in general form, root 3 plus 1 plus I 1 plus root 3, is actually this triangle here. And so from knowing that triangle, we could have written root 3 plus 1 plus I 1 plus root 3. We could have directly written that as 2 root 2, which is the modulus, e to the I 5 pi over 12, which is the angle in the Argonne diagram. So knowing this lesser known triangle, right angle triangle, could save an awful lot of time in a multiple choice exam if you were unlucky